T530, that's the session number. We have 4 papers on the list, and we have 90 minutes to present them. One of the authors, number 3, I have not seen them here yet. So far we have 3 presenters here. If the number 3 does not show up, we can give the time to others to have more discussions. So roughly, every person gets, we assume that number 3 is going to show up. So roughly every person gets about 22 minutes to total. So good idea is that do solid presentation for 15 minutes. Then I let you know that there are 5 minutes left. So you get ready for wrap up. And then leave a few minutes at the end for questions, discussions, and switching from an author to another author. Okay, so the first paper is going to be presented by Dr. Kopi. The title is SerenePulse, a RAP pipeline for real-time physiological monitoring using rPPG and OpenAI LLM. Here we go.
Thank you.
Ball is in your hand.
Good afternoon, everyone. SerenePulse, a web pipeline for real-time physiological monitoring using rPPG technology and OpenAI LLM. High stress in engineering education is well known, and its demanding nature leads to high levels of stress. And as we know, as per research, the economic impact of stress is $1 trillion annually, and it's projected that it could reach 16 trillion by 2030. And a major percentage of college students do seek counseling, and they face anxiety, depression, and so on. The entry barriers to mental health management among students is high cost and also the rare usage of the tools. And normally engineers need proof. So we would like to know what is the level in numbers if we have to believe in it and if we have to manage it. And we rarely do take note of the levels of stress. So the causes of stress are different ones, as you see on the screen, and it leads to negative emotions, inattention, memory loss, and decreased creativity, accuracy, and intelligence. Now, the last line is definitely required by researchers like us, because research contains high creativity involvement, right? And impact of stress on engineers. Engineers, why they have to manage stress is because as engineers, we are responsible for designing and constructing large buildings, bridges, and even when it comes to software and hardware, we have to be responsible, because now the structure is dependent on us, our design. And in this study, we have analyzed the variables usage, and we have seen that it is less, and we have introduced the usage of rPPG technology, which is video-based monitoring. So that is without the help of a gadget or a connected wire or any kind of pulse measurement. Just through the video, we can measure the pulse rate. And we calculate the HRV metrics. And what does HRV metrics give us? It gives an indication of stress levels. Right? So our parasympathetic nervous system gets activated when we are in rest and digestion mode, and sympathetic nervous system gets activated when we are under stress, and the heart rate goes up, the pupils dilate, we start sweating, and it all shows survival modes. And as engineers, we want to see how it relates, how stress is related, and you can see it on the screen how different HRV metrics are changing as per changing stress. So if you have more questions on this screen, I have another slide later on we can go into. So what is the methodology suggested, or methodology we introduced in the paper? We start pre-processing the video signals. So we use certain technology to pre-process, and then we find the regions of interest. So how do we measure the change in blood volume and pulse? We just pick up 3 regions of interest, which is forehead and 2 cheeks. And then we measure the pulse levels through change in color. Because every time the heart pumps blood, the blood volume increases and the color slightly changes. And that the technology is now capable of picking it up. Right. And then we again go through certain kind of processing to find out the detection of the peak. And we pick up certain components, or we split the signals into certain components using ICA, so that we get clean signal which represent the heart pulse rate. And from that we can calculate the heart metrics as we have seen before. And as you can see, finally we get a signal that is clean, where we can pick up the peaks, and then if we calculate the interbeat intervals, we can find the pulse rate, because every time heart pumps blood, it goes up, right? So now we have cleaned it enough so that we can view that change in the screen, on the screen. And then we send this to the LLM, and LLM acts like a psychological counselor, sending us analysis and also suggested practices to manage stress. So this is like the output of the LLM. It could suggest different practices, and we have prompt engineered the LLM to suggest based on different variables. So we did a research on what are the practices suggested by different variables, like Apple Watch, Whoop, Fitbit, and so on. And we made a list, and we suggested that please suggest these to the LLM. So prompt engineering is involved. So the LLM returns with the analysis of the study. And we ran the code. It was long time work to develop the code and develop the accuracy. So right now we are standing at 95% accuracy in heart rate, and there's high correlation when we did the statistical analysis, and the accuracy is really low, and overall accuracy is over 92%. And this is just using only 14 videos out of 56. So we still have the scope to increase the accuracy. So this is like one of the samples. As you can see, 75 is the real one and 77 is the calculated one. So how do we know if it is correct or not? So we used the UBFC FIS dataset, which uses Empatica E4 wristband for precise physiological signal recording. So that is in the dataset itself, they are given the blood volume pulse, from which we can calculate the heart rate and the HRV metrics. So we use this actual data, which is very accurate, to compare with the calculated data from the rPPG technology. So through this, we can use this technology to measure the stress levels and then get the AI help to manage it. And the app is already online, so we have deployed it on Streamlit and it's available. And right now we are developing it still. We have developed a lot after we submitted the paper, and now we are developing it still. And I'm looking for 10 beta testers now who can test it and give me feedback. And that's going on right now, because the work is on the pipeline, not the app. The app now is underway. Right. So these are the slides which I prepared for you, but I have more slides, so I will go with the questions and then I can choose which ones. Thank you.
Any question for him?
Yes.
Have you, given it's an LLM, have you received any kind of pushback from the medical community considering LLM's unreliability?
It's a great question. Okay. But as a prompt engineer myself, I've seen that the inaccuracies occur when we don't prompt it properly, right? And it depends on which model we use, which LLM we use, and so on. So we are using OpenAI, and we have tested it with 3.5, well prompt engineered, and 4.0 is very, very accurate. And also, it's not like we just ask the LLM to give suggestion. There is a lot of work involved in it because we upload DSM-5 abnormal psychology, the book, full book into the LLM, because we can now upload documents. So only through the document, it's first check the document, what are the suggestions in that depending on the symptoms, what are the suggested practices, and then we have certain kind of books which suggest the practices. So that also we upload, and then we sometimes refer if we don't have to upload. So like that we do prompt engineering enough so that LLM hallucination is almost not there.
I'm just not convinced prompt engineering enough is alone maybe to ensure in a medical situation that your AI is going to always deliver the exact results. So I'm sure you have training and everything, but is there any kind of extra safety check you do to ensure that maybe your LLM is giving accurate advice, particularly in mental health situations?
See, what in this project or in this paper it's out of scope, right? Because here we're just looking at the pipeline, and the LLM response is just one last part of it, right? Maybe you can pick it up as the next research and do it. But I have done such projects in the other research areas, and I have not faced any, because first of all, I'm not interacting with the medical community to get a feedback like that. So maybe you can give me a connection like that to understand what they need, and then.
So you haven't used any real patients yet?
No. This is not for patient. We are not using it for in psychiatry or something, right? We are just using it for students and coders. That's it for now. So we're just using, we have Apple Watch. We don't have any psychiatrists there, right? It's shown, HRV data is shown in the Apple Watch. It shows the waves and everything, right? So there's no doctor there, there's no medical confirmation, nothing. It's like that. But when it comes to medical, yes, we will go into that, yes.
All right, I'm a non-computer major,
Okay.
so I was kind of lost when you said LLM.
Okay, sorry. LLM is large language model. So it's like, you heard of ChatGPT. So ChatGPT is an LLM.
All right.
Yeah.
Thank you.
I have a quick question.
Yeah.
The wavelength that you have, is that we can use that like to place that? Like, I know you had it for student at the end. You said that there's a link there and then you can
Oh,
check
that
it.
is an app. Yes.
Oh, that's the app. Right.
Yes,
yeah,
so
I was
I'll
just-
show you that. Yeah.
It's very interesting, the project, by the way.
Yes. Let me see if I
It
can
can
show
be
you. We have
helpful for
time.
students.
We have time, so I'm just going to. Let me see if I can show you. So here, this is like a demo of the app. Okay. So. So here I'm looking at the camera and I'm recording the video. Just 1 minute here, and you can see the region of interest is forehead here. So based on forehead is now checking out. Okay, and here I'm using some emotions because it does emotional analysis also. This app, which is not mentioned in the paper, but if I skip all of that, right? So I'm using some emotions to get some report. So then it'll so it's producing the report. So here the anchor, everything is measured based on your facial expression. Okay, it's not mentioned in the paper, but it is included in the app. So it's interesting because many times we don't recognize what emotions we are going through. So the video can actually capture that quite easily. So does that answer this question? The app, how does it look like? Yes. So so if you go to the link, the app is live, and here you can see, because right now internet is not good, so I cannot show you that. But the basic thing that is shown in the video, you can click, and right now it is a demo on a demo basis, and what you see on the screen, you can get it. But the accuracy is much more than what is in the paper because now we have worked on more. Yeah.
Thank you.
Okay.